Good morning and thank you for having us. My name is Andre Durand. I am the project manager and water resources engineer for Triscuit Engineering, and we'd like to present our final progress presentation for the Crown Point Business Park development. So to give you guys a little bit of a project overview, we were tasked with developing a mixed-use business park in Crown Point, Indiana. The park will be divided into 1 acre or larger lots and include a closed-loop drinking water system. An urban road connecting Maryville Road to Indiana Avenue. The design will also include a 40,000 square foot mixed-use building and water quality best management practices on one of the lots. I'd now like to hand it off to my transportation engineer, Mason Ramsey.
Hello, I'm Mason. I'm the transportation engineer for Triscuit Engineering, and I will begin by talking about my proposed road alignment. It runs from Maryville Road in the west to North Indiana Avenue in the east, and it's about 1,700 feet long along the center line. It contains 2 curves with a radius of 300 and 600 respectively, 600 feet, and it has about a 60-foot right-of-way width and 12-foot lanes. Here's the typical section. As you can see, it's 60-foot right-of-way with 12-foot lanes in the middle, each having sloping 2% with 2% grade away from the center line, 5-foot sidewalks, and then a 5-foot green space in between the curb and the sidewalk. Here's the intersection redesign. It is where North Indiana Avenue meets East Summit Street. It used to be have 2 lanes approaching each side, with one of them being a left turn lane and the other one being a through lane. The capacity, that would not meet regulations, so I improved it to add a second through lane that also doubles as a right turn lane, as well as leaving the second through lane, the first through lane and the left turn lane. There's 60-foot radius and it's about 12-foot lane width, so 60 feet at each approach. And each 2 lanes leaving the intersection will eventually merge back into 1 lane. The detour plan for when the intersection is being remodeled, one direction on the northbound, it goes up Maryville Road, over on Center Ross Road, and down Madison Street, and then on the southbound section, down Main Street or Maryville Road, over on North Street, and then up Broadway. The cost estimate came out to about $1 million and then $1.25 million with contingency. It included about $480K for the road, $420K for the intersection, and about $100,000 for the parking lot. And then here's the parking lot design. It contains about 140 total spaces. Each is one-way angled with the lanes are about 19 feet long and 9 feet wide. And then it also contains the required 5 ADA parking spaces. And now I'd like to hand it off to our structural engineer, Christian.
Hello, my name is Christian Robinson and I am the structural engineer for Triscuit Engineering. Today I'll be going over our Crown Point Business Park development. I'll be going through a structural analysis as well as our connections and then a cost estimate. So as you can see here, I was tasked with developing a 40,000 square foot multi-use 2-story facility. We decided upon the first floor being utilized for office spaces and the second floor being utilized for residential spaces. For the primary material for our framing, we decided to use steel, as steel does have a high strength to weight ratio, especially over long spans. And with the geometry of the building being a square, we do recognize there is a level of compatibility that comes with steel being utilized for the framing, as steel can be cut to special angles if necessary, but with it being a square shape, that is not necessarily going to be the case. We do have in the middle, I wanted to point out one of the differences between the last progress meeting. We did have elevator shafts and stairwells in the corners of the building, but we have since then moved those to the center of the building. As I did find out through further research that having your stairwells and your elevator shafts in the corners of the building does create some sort of torsional issues that would be addressed by putting them in the center. For the stairwell and the elevator shaft, we will share one wall within that center section, so that will all be one centralized area. For the the decking, I decided to go with a 20 gauge metal decking to be able to utilize for the first floor, and that will be cut out for that middle diaphragm there, so it will cover the entirety of that first floor. Something we've also changed since then have been the joist, instead of using our typical beams for the roof framing. So I did do this because of I chose to use an open web steel joist. I chose this because it is going to be lighter than the beams, and so that does contribute to a decrease in the gravity loads that are going to be applied to the structure, as well as constructability costs as well. It is more cost efficient to have joists instead of using beams. For the joists, those are selected using the new cores, Volcraft design tables and design tools. So I took on the different factors that I had contributing to our building to be able to develop the roof joist system for our structure. Here's a 3D rendering of what the structure is to be. Unfortunately, this is going to be the RISA floor 3D rendering as opposed to the RISA 3D rendering. I did have some complications that were not able to be fixed prior to the meeting that prevented me from using the RISA 3D exact model, and I will be willing to answer questions about that later. But nonetheless, I did have the RISA 3D model, we would be able to see the brace framing that we decided to use for our structure. So we did decide to go with brace framing as opposed to moment framing due to economic reasons as well. So we did find that brace framing still provides the same level of stability and stiffness and strength for the building at a lower cost because it does not require as many materials as opposed to the moment framing. And the decking also does contribute to helping resist some of those lateral loads as well, as it does create a load path to go into the columns and then finally into the floor as opposed to just staying within the system. For our connections, for the beam to girder connections, we did make a few assumptions. So we did assume that it's going to be a simple shear connection, so this would not contribute to the transfer of moment, it would just be for the vertical shear. For the beam to girder, we decided to use shear tabs with a minimum of 2 bolts per connection. So as you can see, there will be the 2 bolts connected and welded on the other side. We did also assume 3/4 ASTM A325 bolts to be used in single shear. And then for our girder to column connections, it will be kind of similar, with the exception of there are another option that could be utilized. So we can continue with the shear tab connections, similar to the girder to beam or beam to girder connections. We can also use the double angle connection as well. The reason in which I provided 2 different options for this is because I understand that there are some differences when it comes to fabrication preferences, when it comes to field conditions, or even just the contractor themselves. So I understand that both of these are still going to be sufficient in creating those connections between these members, but I just still want to provide a sense of option between the 2. And then for our construction costs, it came out to about $605,150. For the construction costs, it does just consist of a lot of the structural and framing members that go into the structure as opposed to some of the other costs, including doors, windows, stairwells, and all the other things that would essentially make the building whole. So we did do our best to find the beams that were in RS means that matched the ones that were provided with RISA. As you know, RS means does not have every exact single beam that was provided through RISA after doing the analysis. So what I did was I did an overestimate. So anytime I was looking for a beam that I wasn't able to find, I overshot it in order to get a better sense of the construction costs. I decided to also include the K-series joists as well as the columns and structural concrete. The structural concrete was used for the foundations, whether it be like the column footings or the slab on grade components or any other sort of foundation-related requirements for our floor. And I'll be now passing it on to our environmental engineer.
Hi, I'm Brianna. I'm the environmental engineer here at Triscuit Engineering, and today I will walk you through the final steps in my design. So starting off, I have revised my Hardy Cross method. Originally, I had the design flow of 6 CFS, leaving the junctions E and F on the east side of the site. However, I have revised that so that this design flow is exiting at the junctions D and H. This is so that the design flow is centralized, so all of the future businesses have easier access to the design flow. Next, I completed my hydraulic analysis using Bernoulli's equation, which which I've provided for you here. Previously, I had yet to include the head loss due to the fire hydrants. This time I did include it, of course. That equation is provided for you as well. The flow rate I used here is the fire flow that I calculated last semester, so the 2,500 gallons per minute. And then the length of the pipe, that is referring to the length that connects the fire hydrant to the water main. So there is a 5-foot cover requirement, so that is the length. However, there is one instance on the site where the fire hydrant, if I only did the vertical connection, would have ended up in the middle of the sidewalk, which defeats the purpose of the sidewalk and makes it inaccessible. So I branched off horizontally and then had that vertical 5-foot connection in order to make sure that all of my fire hydrants that run along the proposed designed road run in between the curb and the sidewalk. So after performing my hydraulic analysis, I was able to get the pressure at each of the junctions in the system. The lowest pressure in the system is at junction B at 32 psi. Originally, before I accounted for the head loss due to the fire hydrants, the lowest pressure in the system was at junction G. It does make sense that the lowest pressure has changed to a different junction now, because pipe BH has the most amount of fire hydrants within one segment, being 4 fire hydrants. So you can see how important including this head loss due to friction because of the fire hydrants is, and how it ends up changing the pressure within the systems. 32 psi does exceed the minimum requirement of 20 psi, so the network is using an 8-inch PVC pipe. Here, I just provided you a plan view of my entire site, including the placements of all of my elements. So that includes the gate valves that are placed at each of the junctions, as well as the fittings that are placed every time 2 pipes come together. It also includes the placement of my fire hydrants, which are 350 feet apart from one another as required. And it also includes this 20-foot wide easement that is required for any utilities that does not run within the right-of-way of the road. And lastly, I have my construction cost estimate. I determined this using RS means, the total bare cost, which accounts for labor as well as the material cost. So the elements in this construction cost include my 8-inch PVC pipe, all of my gate valves and my fittings, all of my fire hydrants, as well as my trenching and backfill. I determined the dimensions of the trenching and what types of materials need to be used for the backfill from the City of Crown Point standard drawings. And in the end, with a 20% contingency to account for any materials wasted during the process, it comes to about $200,000. So now I will hand it off to our water resources engineer.
So as a water resources engineer, I was tasked with 3 separate things. Flood control for the runoff generated by the 100-year storm, achieve 80% suspended solids and 70% total phosphorus load reduction on a chosen lot, and infiltrate 1 inch of water from all impervious surfaces. So as a review for this site, as we can see, there are wetlands, flood zones, and electrical and gas easements that we have to avoid while designing the dry detention basins. The biggest challenge I faced while doing this was the seasonal high groundwater table. We assumed that this occurred at the wetlands, and per NDOT, we want to be at least 3 feet above this for our dry detention basins. That's why my detention basins are rather shallow and have a large footprint. So as a review for detention A, this is in the southern portion of the parcel. It's split between a west of the road and east of the road section, and connected by a horizontal concrete culvert. We made this concrete culvert horizontal so these 2 ponds can share an equalized flow as needed. Previous design work includes getting the volume of the detention basin, sizing the outlet to limit the outflow to 5.3 cubic feet per second, sizing the emergency overflow weir, and designing the horizontal concrete culvert. And for detention B, this is in the northern part of the parcel. Similarly, the design work included getting the volume of the basin, sizing that outlet to limit the outflow to 1.3 cubic feet per second, and emphasizing the emergency overflow weir. For level pool routing, we applied level pool routing to evaluate the detention basin performance. We developed a stage storage, stage discharge relationship, routed the inflow hydrograph to generate the outflow hydrographs, and evaluated the peak flow reduction and storage requirements. And for my water quality, there are tree boxes that are included in the parking lot. They have an under drain to convey water to the downstream rain gardens, and they provide 60% total phosphorus removal and 75% total suspended solids removal. Outside the parking lot, there are tree boxes that do not include an under drain. They're a little bit deeper to promote infiltration. They provide 70% total phosphorus removal and 75% total suspended solids removal. In this design, we have 2 rain gardens that capture and treat runoff not treated by upstream practices. They provide 70 to 90% total phosphorus removal and 75% total suspended solids removal. And then the vegetative filter strip in this design is primarily used as pre-treatment for the downstream rain garden. And then for the construction cost estimate, most of my BMPs were estimated using the life cycle costing module that can be found on Georgia Tech's online library. And some assumptions that were made, we used Indiana average cost with subcontracted labor, 10% excess material purchase, and since the module gave us the cost in $2020, we had to use the inflation calculator to get into $2026. And as you can see, for construction, we get $3.7 million, and operation and maintenance for 30 years is $13.7 million. Thank you, and are there any questions?
Your cost, the final cost seems to be like the $13 million for the stormwater management system, if you want to call it altogether, seems to be very high, like 13 million, 13.7.
That's for the operation and maintenance of 30 years, so generally it's around 6 to 14% of the total cost per year, so that's why it's so high. And this was just given to me by the life cycle costing module.
So that's as a total present cost?
Sorry?
The 13.7 million is a total present cost, like all that 30 years converted back to today's dollar?
Yes, yeah.
Did you consider using a different type of system, like a piping system instead of swales in this case? Like, because I'm looking at the numbers between the detention basin and the swales, they are the highest. And so, did you consider alternatives to reduce the cost?
I did not.
Thank you. Christian, I have a couple of questions for you. Number one, on figure 111, you showed the connection with the 4 balls. Did you borrow that drawing, or you did it yourself?
So I did have a very crude CAD drawing that I used, and due to my, I guess, like, inability of certain art skills, I did have it rendered to have a more better representation.
The reason I'm asking, because the bolts are going through the flanges of the W section in here. So you look at those bolts on both sides, the top and the bottom there, and so how the people in the construction field want to put those bolts?
That's a great question. That's something that I did not consider, and I appreciate the comments.
Otherwise, I am impressed with your, like, the depth of all the joists and the members of the other drawings, so you kept them the same depth in there, which is going to make life easy for the architects, actually, as you go through that. However, where do you want to put the utilities, air conditioning units and the heating units? Is there a specific place, or are they going to go on the roof?
So that was something that admittedly was something I considered initially, but as we progressed further with the design, that was something that respectively did get lost. That could be something that we could include onto the roof, but that might be something that we could just include externally to the building that would lead into it.
The reason I'm asking is just simply because you have the same size of joists,
Yeah.
and if you have those units, the AC units, on the top, then you have concentrated loads coming on those joists. So I expect that they will be larger in size than the rest of the other, wherever you locate them. Or typically you work with the architect to be able to see where you're going to put things in this case. Oh, Brianna is expecting it wasn't. I'll pass. I let somebody else ask you.
So I have some questions, and I guess I'll start with you, Brianna, since I do have a question for you.
Oh, okay.
So when you said you moved the fire hydrant so it's not in the sidewalk, did you adjust then the head loss? And if so, how did you adjust the head loss for that hydrant?
So, okay, so I counted for the head loss using the fire hydrant, the friction equation. Realistically, there would be another head loss because of the transition loss, so there would be more of like a T connection there. However, it would have been pretty small of a change in the head loss. And so I was kind of looking at this as more of a like, overall, I need to make sure I'm above 20 PSI. So something as small as the T connection that would have happened there in the transition because of that, I essentially ignored it because it was so negligible in the overall schematic, but the friction loss is accounted for in that little, like, the little L is made.
So you just made the L longer?
Yeah.
Yeah, okay. Okay, thanks.
Mm-hmm.
And then Mason, so was your intersection a signalized intersection? Yeah. And then did you mention the level of service, like now and then 30 years from now? Do you know what that would be?
I believe that the level of service was an F. The current level of service is a C. With the new proposed, like the future work with the current intersection, it would go to an F. And then with the changes that are being made, including the future, it would bring it back up to a C.
Okay, thanks. And then Andre, so your tree boxes, do you have pre-treatment? You mentioned filter strips for pre-treatment for like one of the rain gardens, but what about the tree boxes, especially those in the parking lot?
Right. The tree boxes will include a sump/catch on the front to catch all the larger debris before the water enters the actual treatment.
Okay, thanks.
So Andre, on your layout of the site, you put the rain gardens and I think the swale kind of close to the building. Are there any concerns about it being that close as opposed to like tucked away in the corner of the site?
So when I did my research for where I could put my, vegetated swale, said it needs to be at least 3 feet away from the building. So that's what I put it at, exactly 3 feet.
All right, so it's as close as it can be.
Yes. Yep.
And, right.
I was trying to save some space and not buy more land than we already had to.
Mm-hmm. Yeah, makes sense, definitely. And Christian, you mentioned on the 3D, going to RISA 3D, difficulties with the bracing.
Yes.
Can you identify where you would have put kind of bracing or how that?
So the bracing, it would have just been on that first floor. It would have been like diagonally across the inside of the bottom of the structure.
So you put them on around the building. Did you brace with an X or with?
It was just one diagonal, not like an X shape. It was just like one.
Okay.
Yeah.
Wow. And what kind of messages were you getting from these?
So it wasn't necessarily the messages I was getting. It was more so like the actual imagery itself. So to try to make a long story short, I made a copy of the RISA floor, and I made all of the, or I made a copy of the existing one that I had. I made a copy of that, and I made all of the gravity loads lateral just so I could get it to stand in RISA 3D. But whenever I would like get the 3D image to render, it had like framing that was like outside of the building, essentially leading into it. And it was like trying to go through and delete all of those and rearrange it. It just proved to be a bit difficult trying to manage the amount of just like external beams that were for whatever reason almost like external to the building leading into it. I'm not sure exactly why that was, but just trying to clean up the image just proved to be a bit difficult as opposed to just using the RISA 4 3D rendering.
Thank you.
question to the location of the bracing in there. When will you consider having a moment connection instead of the cross bracing in this case?
I think from my research that moment bracing is more appropriate for shorter buildings in a sense. So since ours has an elevation of overall of 21 feet, that would not necessarily be too tall for a moment framing, but it'd be more so appropriate to have the brace framing, especially for like commercial buildings as well. So just from my personal research, I found it to be more, I guess, appropriate to use the brace framing as opposed to the moment framing.
One of the problems with going last, so all my questions have been asked already. I was going to ask about level of service. I was going to know the double angle connection with the bolts going around. So really, I only have one question for Brianna.
What could that be?
What would that be? Brianna, what did you find as the most challenging portion of this project for you?
I mean, it was just easy peasy. No, I'm joking. If I want to give a general, probably, I think I said this last semester maybe, all of the assumptions I've had to make along the way and how I don't have the experience to back up those assumptions. So I have definitely been bothering my advisor many times or trying to do my own personal research. If I wanted to be nitpicky though, and anyone that's been around me all this year knows this, anything to do with the needed fire flow or any of the fire hydrants. I've never done it before, and so trying to have an understanding of it, I mean, I think that was a little bit salt there, because I've never done it. It was hard. Doing the needed fire flow in the beginning of last semester, I was, I think, maybe a little more unconfident in myself, but it all worked out in the end, and now I understand fire hydrants, and I'm ready to design them at work.
Very good. Thank you.
Any other questions? Okay, great, thanks.